In the previous video lecture, we defined the instantaneous center of zero velocity. We said that the instantaneous center of zero velocity is a point that may or may not lie on the body itself, but this point has a zero velocity, as if this body is rotating around this point at this instant. And why is it useful to find and locate this point? Because in fact, if I find this point, the velocity analysis will be very simplified, because now the body is rotating around this point, and now the velocity of any point on this body will be equal to the angular velocity times the distance from this point to this instantaneous center of zero velocity. Which means, guys, whenever I can locate this instantaneous center of zero velocity, my velocity analysis will be very simplified. So let's locate it in different cases. The first case, in fact, is whenever I know the velocity. I know only one velocity of a point on this body. What does this mean? I know its direction and I know its magnitude. So if I want to find the instantaneous center of zero velocity, I have to find it from this velocity. In fact, I know that if I have IC, then the velocity A will be equal to omega times ICA. Which means, guys, ICA is equal to VA over omega. So I know now the distance between IC and A. If this is A, IC could be here, or it could also be here. Now, why it cannot be here, for example, on this oblique line, such that ICA is equal to VA over omega? Why? Because in fact, this IC does not belong to the line that is perpendicular to VA. Don't forget, guys, that this IC should be located to the line that is perpendicular to VA. Why? Because VA in vector form, so don't forget, guys, the first rule, VA in vector form is equal to VIC, which is 0, plus omega cross the radius, or it's not the radius, it's the position of A with respect to IC. Now, what does this mean? I know that if VA is the answer of cross product, then VA should be perpendicular to omega and perpendicular to RAIC, which means it's perpendicular to AIC. And that's why IC could be only on this line, all right, which is perpendicular to VA. Now, why I have to take IC on this side right here and not this side? Because in fact, guys, if you apply the right-hand rule, let's assume that IC should be on this side, all right? If IC should be on this side, then RAIC will be towards A, so it is in this direction, but I have to start by omega. Omega cross RA with respect to IC should give me VA in this direction. Now, what is omega? Omega is moving, or it is the angular velocity in clockwise, as it is shown here, all right? So this is omega, which means omega is towards you, all right? Cross RA with respect to IC. I'm saying that RA with respect to IC is in this direction, all right? So it is in this direction, all right? What does this mean? This means that V, so I'm going to repeat, if this is omega and this is RAC, V will be downward, which is not the case here. V is upward. And this means what? This means, guys, that if omega is towards you, RAAC should be in this direction, so that VA will be upward, all right? And this means that RAAC should be in this direction and not in this direction anymore, all right? So from the right-hand rule, you can locate IC. I know that IC should be on the perpendicular line to VA. I know that the distance between A and IC should be equal to VA over omega, and I know the location of IC from the right-hand rule. All right, because I have here a cross product. So this is the first case. In this case, I know VA in vector form, and I know, of course, omega. Now, in the second case, I I have two velocities, and in this case, it's very easy to find IC. Why? Because I know that IC at this instant, which is the instantaneous center of zero velocity, should be perpendicular to VA and should be perpendicular to VB. So if I plot the two perpendicular lines, their intersection will be IC. Alright? So that this is a perpendicular line, IC belongs to this perpendicular line, IC belongs to this perpendicular line, then the intersection between these two lines will be IC. And then I can find, in fact, any velocity, all right? So if I have a point E here, what should I do? I should only to find the distance between E and IC, and then VE will be omega times RC, E. Then in the third case, what if I don't have an intersection between VA and VB? What does this mean? What if VA and VB are parallel? If I don't have any intersection between VA and VB, I can also locate IC. Why? Because I know, in fact, that omega AB is equal to what? It's equal to VA over ICA, and it's at the same time equal to VB over ICB. And this means since VA is parallel to VB and VA over ICA is equal to VB over ICB, I have here two proportional triangles, all right? And in this case, my triangle would be ICA, the end of VA, and the second triangle would be ICB, the end of VB. Alright, so in fact, if I do the intersection between AB and the ends of these two velocities, this intersection will be IC. And the same also is applied here. So if VA and VB are parallel in the same direction, then of course I have to do the intersection between AB and the ends of VA and VB. Now, what if VA in vector is equal to VB? So if VA is equal to VB, then I'm going to have this one. Let's say this is A, this is VA, and this is B, this is VB. And this means that my intersection will be infinity. And this means also that ICA or ICB will be equal to infinity. So what should I do here? And why do I have an infinity position for the instantaneous center of zero velocity? In fact, what is the case at which the velocities are equal in vector form? This is the case of what? This is the case of translational motion. In translational motion, if I don't have any rotation, VA will be equal to VB. And in this case, omega will be equal to 0. There is no angular velocity. So if you go back here to this equation, ICA is equal to infinity because they are parallel, then omega will be equal to 0. So this is the case of translational motion. If I have a general plane motion, VA will not be equal to VB in vector form. Now, this is, in fact, our three cases that we can encounter in order to find that, in order to locate the instantaneous center of velocity. Whenever you locate this instantaneous center, you can find V, the velocity of any point at this beam, by only applying the scalar form omega times r, knowing that this V should be perpendicular to the radius joining IC and my point. Thank you.